Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
This is Introduction to Corda Distributed Ledger Technology Development. This course is a presentation of Coding Bootcamps. This session is the Introduction to Corda and how R3 Corda works. A little bit about myself. My name is Jim Sullivan. I have a Bachelor of Science in Electrical Engineering and an MS in Computer Science. I also hold an MBA. I am an IBM Master Instructor, an O'Reilly Media Instructor, and Senior Blockchain Developer for DC Webmakers. As a software engineer, I lead an expert team in blockchain development, also DevOps, cloud applications, application development, and the safe agile methodology. And I work with blockchain platforms such as Hyperledger, Ethereum, and Corda. Some prerequisites, recommended prerequisites: introduction to Java programming, learn Kotlin programming by examples, and introduction to blockchain technology. Please check back with Coding Bootcamps on all of these courses. The topics we'll cover are, we'll find out what Corda is. I said distributed ledger technology and not blockchain. They are the same thing, but they're not the same thing, and we'll talk about that. Getting set up, and we'll actually write a Corda distributed application, or CorDapp. We're going to learn about Corda states, Corda contracts, and Corda flows. And then we are actually going to run our CorDapp, or our Corda distributed application. This is what it looks like. It may look complex, but it's really not all that complex. And some of the takeaways, what you'll learn by finishing this class: we're going to learn about Corda states, Corda contracts, Corda flows, and the workings of the Corda distributed application, or CorDapp. Some follow-up classes: introduction to blockchain cybersecurity, learn Solidity programming by examples, Hyperledger Fabric for developers, Ethereum blockchain development, Hyperledger Fabric for system administrators, and Hyperledger Sawtooth for system admins. See you in the session. Welcome to this course, Introduction to Corda for Distributed Ledger Technology Development. This is a presentation of Coding Bootcamps. My name is Jim Sullivan. I am your instructor. This is our lecture session, and we will go through mostly lecture. We will have intermittent demos, and at the end we will go over the lab assignment. This lecture session is Building Distributed Ledger Applications with Corda. This is our agenda. So we'll discuss what is Corda. We'll discuss getting set up for this course. We'll discuss writing our CorDapp, or Corda Distributed Application. So CorDapp is an abbreviation for Corda Distributed Application. CorDapps have states, which we will discuss. CorDapps have contracts, which we will discuss. And CorDapps have flows, which we will discuss. And then finally, we will review running our CorDapp, or our Corda Distributed Application. Some highly recommended prerequisites for this course: if you are unfamiliar with either Java and/or Kotlin, please consider taking one of the following self-paced courses: Introduction to Java Programming, or learn Kotlin by examples, Kotlin programming by examples, or both. Both are available through Coding Bootcamps. Also, if you are unfamiliar with blockchain technology or distributed ledger technology, it's recommended that you take the course Introduction to Blockchain Technology or Intro to Blockchain Technology. All three of these courses are available through Coding Bootcamps. Let's discuss what is Corda. So Corda is what we call a permissioned network to communicate on a need-to-know basis between entities about what we'll call a shared set of facts. So to understand Corda, we need to understand how traditional blockchain networks are structured. So in traditional blockchain networks, like Bitcoin, like Ethereum, all nodes are peers, and they all contain a full copy of the ledger. Each node on the network is solely identified by an anonymous public key rather than having a recognizable identity. Messages between the nodes on the blockchain network are passed unencrypted using a gossip protocol, and that gossip protocol distributes the message to every node on the network. Clearly, this does not meet the needs of real businesses. When real businesses strike legal agreements or transactions, they strike these agreements with legally identifiable counterparties and not just anonymous public keys. Real businesses need to keep the details of the transactions private from unauthorized third parties. So this is obviously highly desirable for business and strategic reasons, but for legal reasons as well. So to meet the needs of businesses, Corda is architected differently. Before joining the network, each node undergoes a KYC, which stands for Know Your Customer. The Know Your Customer process has the customer go through steps to obtain an identity certificate. Upon joining the Corda network, the customer publishes the certificate indicating their legal name, IP address, and public key. And this is all published to the Corda network map service. Now, all of the nodes can use the network map service to transact with all of the known counterparties using private point-to-point encrypted messaging. So here we have our Corda network, and we can see a notary pool. So by looking at one of these nodes, Titan Technology Partners, we can obviously see the legal name, the address, and the public key. So now this node is now available to conduct transactions, private transactions, with this node, Bayes Transcorp, and the Colorado River Authority. And the notary pool validates certain parts of the transactions to indicate that they are indeed validated and desired transactions. So let's discuss pluggable consensus using notary pools. So the notary pools, like we just saw, use what's called a Byzantine fault-tolerant consensus. And so really what the nodes are there to ensure is how does Corda prevent double spending? So a big problem with blockchain networks was how to prevent double spending. So in Corda, double spends are prevented using notary pools. And a double spend would mean using the same asset more than once in a transaction. It'd be like using the same dollar more than once to buy different goods. So a notary pool is a set of nodes, mutually distributed, and again using the Byzantine fault consensus algorithm. Each transaction is signed, and it's signed and validated that there is no attempt to double spend in any way. Every transaction requires a signature from a notary to be valid. All nodes in the notary pool do not see the contents of the ledger updates. They see only the hash of each transaction updating the ledger and the index of the fact consumed in the outputs of the transaction. So in other words, the notaries don't see the actual transaction. The transaction is hashed. So we can see here a hash right here. So that way the notary is aware of the transaction, and then we can see the identifiable index of that hash. So let's discuss here Corda nodes and what they do and what they abstract away from the user. So what are these nodes and what do they do on the network? So we can think of Corda nodes almost as blockchain black boxes. They provide what are called user-defined flows that allow the node to perform a set of actions, usually to update the Corda ledger. And then they provide the ability to read back data from the ledger to see the results of the executing flows and transactions. So a flow is really a set of steps that are involved in a transaction. In this way, the node serves to hide all of the complexities of distributed systems and cryptography and data management from the user. So this includes messaging, storage, peer discovery, data distribution, concurrency, transaction recovery, signing, and more. So we can see here, Corda is abstracting away here a lot of these details. And the idea is to make the transaction as seamless as possible, as seamless as using your credit card on an e-commerce site. And again, all of this complexity is used to abstract away or shield the user from the complexities. Here is the flow. This is a Corda flow, and you can see here it is a set of steps to complete an action or a transaction. So we see here node A, which is a user, an organization on the network, proposes an update. This is an update to the ledger, so this could be an exchanging or of cash or something of value, some other asset. A check is made of the update to make sure that the asset is in order and that it is owned by node A. There is a request for a signature. Node B here then checks and makes its updates and then signs the update. And then the transaction is sent down here to the notary pool for another signature to, again, validate. There's no double spends and other transaction validations. Then the record is made on node A and the record is made on node B. So this entry here to the ledger is done on both node A and node B. And the notary pool gets the hash. And the 3 signatures are also sent from the notary pool. That is the signature from node A, node B, and from the notary itself. So again, just to summarize this first section, Corda is a unique blockchain or distributed ledger technology platform that allows private transactions between legally identifiable counterparties. And once it's set up, it's quite easy to use while maintaining the benefits of traditional blockchain. And that's done really from behind the scenes. Let's discuss getting set up for our course. So download and install, well, make sure you have the properly supported JVM here, or Java Development Kit or Java Virtual Machine. Minimum supported version we can see here is 8.1.3.1. Also the IntelliJ Community Edition. The Community Edition is free. The currently supported versions are 2017, 2018, and 2019, all of IntelliJ Community Edition. However, I have used 2020, and we'll actually see 2020 in some of our examples, and it runs fine. You have with your training materials 2 zipped folders, one called Corda Training Template Master, which has our exercises that we'll actually work on. And then also included are the Corda Training Solutions Masters. So these are 2 zip folders containing the same project. The Solutions Master has the solutions for the exercises. We have an asymmetric presentation here, so we don't get the opportunity to ask questions and go back and forth with one another and collaborate. So having the solutions to make a comparison when you're doing the exercises is quite valuable. Once we have IntelliJ downloaded, what we'll do is we will click Open Project from the splash screen, or you can click File, Open Project. In our instructions, we are going to unzip these zipped folders to a folder called Corda Training. So after we click Open Project, we'll navigate to that Corda Training folder and select one of the projects and click Open. In this case, we want to look at the Template Master project first. If we're prompted to import Gradle projects or we get any Gradle prompts, please accept all of them. Let's discuss writing our Corda distributed application, or CorDapp. So we're going to write a CorDapp for an IOU asset. And this is a good asset because it's obviously an asset of value. It can be traded between companies or individuals. and we don't think about them a lot. And an
Thanks for watching. Feel free to add your questions as comments down below.
IOU asset is actually a promissory note, but the name here is a lot shorter than promissory note, so IOU asset is fine. We're going to have three classes for our CorDapp. We'll have what's called an IOU state class that will represent what we call states on the ledger. So they are similar to Bitcoin inputs and outputs, or frankly, it's similar to any kind of a ledger, whether it's for dollars, inputs and outputs. So I have an IOU, and I either get paid on it, either get paid fully or I get paid partially. And then there's the IOU contract class that governs the evolution of the IOUs. So here we have the rules of value inputs. Are they equal coming from both parties, and signatures. And then finally we have the flow class, like we saw. It's building that transaction, gathering the set of steps, gathering signatures, reaching consensus, and then finally updating the ledger. So this means I'm going to do a brief demonstration. So here we have the downloading of IntelliJ. So I just navigated to the link provided, or I just searched on IntelliJ Community Edition. So you can see here you can download the Community Edition and just follow all the prompts. It installs really like any other product, like any other Windows or Linux type product that uses an install wizard. Here I've opened IntelliJ, and I went through the steps to open our project. Again, File, Open, and we can navigate to that Corda training and open up our project. And we can see here we have the classes that we discussed. We have a contract class. We have our flow classes in a flow package, a contract and a contract package, and a state class. So we will be working with these classes as we are reviewing how to build our Corda distributed application, or CorDapp. And before we move on, just a few things. We will have a brief demonstration on how to configure the setup and the colors of the IntelliJ. The out-of-the-box configurations are not really the best. I know I don't like them, so we'll go over how you can make some updates to those, and we'll also discuss where you can see the instructions for updating and reconfiguring the IntelliJ environment. So let's discuss states, Corda states, the states section of our Corda distributed application. So each node only sees a subset of states on the ledger. So with Corda, privacy is the most important requirement for businesses on the Corda network. Yet traditional blockchain architectures share every fact with every participant on the ledger. There is no privacy beyond the anonymity of the public keys. And with Bitcoin, if you take a look, it's quite anonymous. All you see are the public keys out there. If you go on to any blockchain explorer and look at Bitcoin transactions or Ethereum transactions, you never see a name. You just see that anonymous public key. Corda, on the other hand, only shares information on the need-to-know basis. So here we have a diagram where each of the big gray circles represent a party on the network or a node on the network. And in our case, we have a network of 5 parties, and the nodes are called Alice, Bob, Carl, Demi, and Ed. And we can see here the smaller colored circles represent the on-ledger facts known by each party. So if we take a look here, Alice and Bob only know this fact, fact number 1. So this is the ledger entry that's visible to Alice and Bob. And if you take a look over here at this matrix, you can see here Alice and Bob know about fact number 1. That is an entry on the Corda ledger. If we look at entry number 2 is only known by Carl and Demi. And if we look over here, entry number 2 is only known by Carl and Demi. So these are 1 and 2 are entries to the Corda ledger. But notice the entries are distributed throughout the nodes on the Corda network, different from Bitcoin and Ethereum, where every node contains a full copy of the ledger. This distributed ledger ensures that the nodes are only aware of transactions to which they are permissioned to know, or that they are entitled to know. And again, we can see again, Carl and Demi also share fact 3, and we can go on and on through this matrix. Carl and Ed have 9, 4, and 3. Ed and Alice have 7. So take a look at these. Well, this looks like a Venn diagram, so you can see the facts that all of the nodes have in common, and we can also see it here listed on this matrix. And let's talk about a little bit about the Corda State API. So the Corda States have a library or an existing class called Party, and we'll take a look at that. That is, it's available as a import through Java or through the Kotlin language, and then also contracts or the ledger through contract states. The IOU state class implements the contract states. We'll actually see that. So we see, especially for those of you that know Java, we know about interfaces and how different classes can implement interfaces. Well, that's what's going to be happening here with Corda. So we have our IOU state class, which will implement contract state. And so either through the Kotlin language or through the Java language, it does the exact same thing, implements an interface. We can see here the properties. We have an issuer, which is of type party. We have an owner, which is of type party. And then we have an amount, which in this case is of type integer. And then we have our participants, the issuer and the owner. So here, this means I'm going to do a demo. So let's take a look at our IOU state. So I moved back to our solution that's opened up here in IntelliJ, and I moved down here to our contract state, and we can see our contract state class. And you can see here we are importing some libraries. And if we take a look here, even though this is Kotlin, we can see we are implementing. So we see the belongs to or implements the contract class. So state implements the contract class. You can see we have our amount here declared, and we have our participants, lender and borrower, that are of type party. So party, and we can see up here, is imported with Corda. It's an existing library or an existing class, which we will use. And here we'll also be defining an amount that's paid. We will be getting the lender and the borrower. And then we can see functions here. So we have our class, just like in Java, and methods are called FUN or functions in Kotlin, same thing. We can see here that we have a payment function, and we also have a new lender function here. So this is how the states are implemented in our CorDapp. And also, I encourage you here to read through these comments. These comments are quite good. They make a very thorough explanation of what's going on here. And if you look through this, if you are inclined for programming in any way, you can see how this makes a lot of sense and how it's quite straightforward. So to summarize our states section, states again are shared facts that are distributed on the need to know basis. So we can see with Corda, all of the ledger entries exist distributed throughout the network. There is no one single ledger that's on every node. The shared facts are represented using states. Those are instances of classes implementing the contract state interface. The contract state classes should have participants who will be notified of updates and additional fields to capture shared fact information. Hi, welcome to this video on our contracts component of our Corda distributed application, our CorDapp. So we saw earlier that in Corda, the ledger is a set of shared facts, and the ledger is updated over time. So nodes update the ledger using transactions. A transaction is a proposal to modify the current ledger in some way. So a transaction is a proposal. To update the ledger, the transaction has to be validated. So a transaction consumes some kind of existing input state. So there is an input state. Maybe I have $10 and then I pay that $10 to Tom. So me having the $10 is marked as historic. I can't use that $10 anymore. That $10 has to be used by Tom, and that will be the new state of the ledger. If a transaction proposal is approved, the input states then are marked as consumed or historic. Again, I can't use that $10 anymore. While the output states are created and they become the current state of the ledger. So now any new transactions with that $10 will begin with this state because this is the new state or the new state of the ledger. So if we look at this a little bit bigger here, we can see that there are input states. These could be payments, these could be transfers, could be real estate, healthcare, many different types of assets. We don't have to begin with an input state. We can just strictly have an output state. And you can see that just like we had that example where I made a payment, that person then makes a payment to somebody else, and that all these transactions evolve the state of the ledger over time. So the future transactions update the ledger over time. And when approved, the output states will become the new state of the ledger, and the former or the original input states will be marked as historic. They'll still be there for historic purposes, but they cannot be used in any transactions. Transactions can be ambiguous, so just by looking at the transactions and the input and output states, it can be hard to tell if what the transaction is doing. For example, we see transactions with cash inputs and bond inputs and cash outputs and bond outputs. What is this? Is this a bond purchase, a payment on a coupon, or something else? It's hard to tell what the transactions represent. So Corda gives us commands. So to clarify the intent of a transaction, we use one or more commands. The commands say what the ledger updates actually, or what the transaction represents. So for example, in this transaction, the commands indicate that we are transferring cash from one party to another, and we are also doing this to make a payment on a bond coupon. So in this transaction, we see that it is representing doesn't represent a bond purchase. It represents the payment on a bond coupon, and that's what the proposal is. So we can also see here each command, and again the commands, is associated with a list of required signers. So right here we need the input from the owner, and we see owner here Alice, and then we see owner here Bob. So the cash transfers must be signed by the owners of the cash. So we need an owner here and an owner here. And the coupon payments must be signed by the bond issuer and owner of the bond. So the input here is the owner and the issuer of the bond. So we see here the owner and the issuer and owner and the issuer. For this transaction to be validated from a proposal, the signatures must be gathered from all of the required signers that are indicated in the commands. So in this example, we need to gather signatures from the cash owner, which is Alice, the bond owner, which is Bob, and then the bond issuer, again, which is Alice. In other words, Alice and Bob would be required to sign this transaction to make it valid and to have the ledger updated. So our Corda API, so our commands with parties, so our commands are implemented with the API commands with parties, and our inputs and outputs are implemented with the ledger transactions. And it's time for a demo. So if we take a look here at our contract class,
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
you can see here our contract class implements the contract interface. We can see here our commands. So in this case, we have issue, transfer, and settle. These are our commands. And if we scroll down here, we can actually see these commands in place. So we see the command issue here a little bit later on in this function, or this would be the equivalent of a method in the Java world. Scroll down here, we can see the command transfer, and there are requirements associated with the transfer. We'll talk about that shortly. And we see the command settle and some requirements there. So you can imagine as these commands are being executed, there are certain requirements that need to be met before the transaction is validated. So again, we can see here that this is quite straightforward. Please read the comments as you go through. That'll be part of our assignment, is to read the comments on all of these so we gain an understanding of the logic. The coding we can always pick up, but understand the logic about what is actually running here. And then the commands will also, like we said, will gather signatures. So if we read through here, you can see that we do our checks, and then we are then checking on any kind of property changes. And then down here we have our signers and our participants. So our contracts have the logic in here to decide if the transaction's proposals are valid. Again, here is a transfer of cash from Alice for the amount of 3, transfer ownership to Bob. So the first thing, has one cash input and one cash output. Is that true? Well, yes, we see it's true, so we see the check mark there. Then we see, do we have a transfer command? Well, we can see the transfer command there, so that gets checked as true. Is there cash in and cash out? So it looks like that's the case here. There is a cash input and a cash output. And do we have the input owner requirement signature? We have that, so that gives us a valid transaction. And then the ledger would be updated that now Bob is the owner of this cash of the amount 3. So let's take a look at this transaction. Again, we have our inputs and our outputs. We have our owner Alice with 3, and well, let's just go through this. So rule 1 or requirement 1 has, do we have a cash input and a cash output? Seems to be the case. Yes, that's true. Do we have a cash transfer command? Yes, we do. And we need the command is requiring us a signer. Do we have cash in equals cash out, and this means equals here. Cash in 3, but cash out is this amount here, which is almost $1 million. That's a problem right there. That's what we call a contract verification exception. Obviously, this would be an invalid transaction, and the ledger would not be updated, and it would roll back to its current state. So we can see here that to input these requirements, again, that is the requirements are implemented in the contract type. And I'm going to do a demo. So here we can see we've opened up again our contract class, and here we can see our commands. And it says here that no inputs should be consumed when using an IOU. So we could see here it's just checking for empty. Only one output state should be created. So we see here output states equal to 1. A newly issued IOU must have a positive amount. So the amount here is greater than 0. We can see that rule. The lender and the borrower cannot be the same person. I cannot lend to myself. So we see here IOU borrower not equal to IOU lender. And if you look through here again, read the comments, it's quite straightforward here. We could see some other, only the lender property may change. So we can see here we're calling back the lender property. So to update the input and the output. So you can go through here and check that the cash out is being assigned. So you can take a look here at these inputs and outputs that actually validate a transaction. It all, again, is quite straightforward and makes a lot of sense. And all of these are running within the, notice, within the commands. So the commands are validating all of the rules and the requirements for the transaction. We'll actually summarize all of these rules, but before we get into that summary, we can see here this very first requirement here: no inputs should be consumed when issuing the IOU. So there should be no input states, and we're validating here that the transaction inputs are empty. So, well, here we go. Here is a great simplification of what we just looked at. So here is our IOU issuance transaction, no inputs. We have that rule that we saw, and you can go back and take a look again. The amount has to be greater than 0. We have one command, issuer, with a required signer. And again, the output needs to be positive, and here are our participants. So it doesn't really make sense to for an IOU to equal 0 or less than 0. Again, here, if we look through all of our IOU contract, that class that implements contract, we'll see there are no inputs, one output. I think we just saw that on the previous. So we have that one output command, or one output state. We have the one command. Again, you see the one command and the one output state. Well, we see that right here. Output is the IOU state, and the output field is positive, and the command is issue. So we see here the command is issue, and we have a issuer is the required signature. So as we go into our exercises, what we're going to do is go through each of the files that make up the classes, and we don't have a real Corda node or a Corda certificate. It's just not practical, but we can do a simulation, and we will do a simulation. So we're going to use our repositories, the Corda Training Template Master and the Corda Training Solutions Master, and then we are going to run the unit tests on all of those to simulate the execution. So again, to summarize what we saw, transactions consume old states on the ledger and create new ones, or sometimes there are no old states, there's just new states come into existence. Commands indicate the intent of the transaction and also indicate the required signers. Contracts are classes implementing the contract interface, and contract classes should verify transactions and validate that they are indeed valid. So if any rules are broken, a validation exception is thrown. So let's discuss the flows in our CorDapp. So we looked at an example like this a little bit earlier. We see here that there are two nodes that are communicating. We said in an earlier section that the flows are, they describe those sequence of actions that the nodes need to perform when processing a transaction. So we can see here node A, node B. These are the two user nodes, and then we have our notary pool. Node A makes a proposed update for the ledger and then runs a check. Then for the check here, we see they both run checks. There is a sign and update, and the check here is sent. And then we can see here it's sent to node B. Node B executes its check and update and signs the update and then sends it back to node A. Okay, great. And now just to validate that there are no double spends and other rules, the notary will sign the transaction. And then, so we have these three signatures now from node A, node B, and from the notary. The notary sends back the transaction for recording on the ledger back up to node A, and node A then sends the signatures and the updates for recording back to node B, and then we would see that entry into the Corda ledger. So this is just one example of a flow. We can see here that flow logic actually comes from the needs of the business. So again, the business and the developers can put together those sequence of steps as needed. Flows don't always have to update the ledger. They can also run network operations. They can make HTTP calls. So it's really up to the needs of the business and how the developer implements. So again, we can see here flow logic. There is an API for flow logic and an API for a transaction builder. So let's take a look at a brief demo. So let's take a look at our flow classes. Here we have under our flow package, we have our issue flow. And again, I encourage you to go through these and read these comments. They are really informative. But we can see here that we have our issue flow, and we can see here the result will be a signed transaction, or the intended result is a signed transaction. So we see we get a reference to the notary and the key pair. Create that issue command. We can see the command issue here. Build the transaction, and again, we will take a look at this in a little more abstracted detail on a slide. We can see here we verify and sign with our key pair. And let's take a look at the settle flow, and you can certainly read through all of these. For the step one here, again, the idea is a signed transaction, so we retrieve the IOU state from the vault, the current state. We check the party running the flow is the borrower, so we're validating identities there, that our identity is not the borrower. Again, we build our transaction and involve the notary. We check we have enough cash to settle the requested amount and the cash balance. So we check that cash balance amount. We do an if it's greater than the amount. And let's take a look at our transfer flow here. Again, the result is returning a signed transaction. So we can see here that we retrieve the IOU again. The IOU specified linear ID from the vault. The flow can be initiated by the current recipient. So we can see here the lender. Check the new IOU state reflecting a new lender, and create a transfer command again. And then if you look here a little bit lower here, we're involving the notary again with the builder. So please go through these. Again, these are very well commented. And again, you don't have to be an expert coder to really understand what's going on here. But it's good to see all of these classes and how they will actually run. I'm going to come back here to the IOU issue flow. What we're going to do here is in our next slide, we're actually going to review the steps of the flow, the sequence of actions in detail. So we'll see how we get our reference to the notary. We'll see our code as far as calling the transaction builder and creating the state. So we'll go through all of these steps here, and then ultimately the signing the transaction. We'll just take a look at the logic that's involved here. So as promised, again, if you get a chance, please take a look back at the class we just looked at, IOU issue flow. But if you remember, in the sequence, we chose a notary for the transaction, and then in our code, we created a transaction builder, created the IOU state, you created an issue command. So take a look at all of that. And so this was what was really custom for our transaction. And then again, we verified the transaction, signed the transaction, and notarized and recorded the transaction. And if we remember that from this last step here, if we remember that from our flow diagram, So again, back to our flow diagram for 1 second. Here's our notary pool. We are notarizing and then recording the transaction. So for your assignment, please take a look at
Thanks for watching. Please like and share this video.
each of these classes, the tests, and the actual source code in the contract. Again, these repositories are in the Template Master, Corda Training Template Master, and Corda Training Solutions Master. There'll be instructions on how to run them and also a demonstration on how to run them. And finally, a summary of our flows discussion. Flows automate the process of updating the ledger. Flows are classes implementing the flow logic interface and the steps needed to complete a transaction. Flow logic classes should override or call, which defines the flow steps, and transaction builders are used to construct the transactions. Welcome back, and let's have a look at an example of the running of a CorDapp. Now, we don't have a certificate here, and we don't have an actual Corda node. However, though, we can go through a simulation. So what we'll do for this lesson is we will have a demonstration of the running of a CorDapp. This will be running it without a user interface. It'll be more of a command line type of a demonstration, but it still is a demonstration where we will be able to see the participants, the borrowers, the lenders in the transactions. So let's have a look here at a video where a CorDapp is actually run.
Let's give it a run. First, before we can run our CorDapp, we need to deploy our CorDapp. And what we're going to do is use a task called deploy nodes that will automatically create a local test network of nodes that we can run the CorDapp on. So if we open up the build.gradle file here, we've got this deploy nodes Java task. And this is a task that will basically build a local network of nodes in this build/nodes folder. You define each of the nodes using this syntax here, so a new node, and then you provide their name. They're a notary, you specify the type of the notary, you give them a P2P port for messaging between nodes. And then for the nodes that are non-notary nodes, we're also going to give some RPC ports. So RPC is how the node owner would speak to their node. We'd list the CorDapps here. We'd provide some RPC users who can log in and perform actions, i.e. run flows on the node. So we've got a party A here in London on messaging on port 10,003 and available to connect to via RPC on port 10,004. We've got a party B, etc., party C. And so we're going to run this task. It's going to create a bunch of nodes configured to run together on our local machine. So I'm just going to open up the command line here. So I'm just going to move to where the bootcamp CorDapp folder is. And here I'm just going to do run gradle clean deploy nodes Java. So Gradle is our build system when you're using this build system to run our deploy nodes task. So it takes a little while, but we can go and look at the outputs once they're done. So here we're creating 4 directories, one for each node. So a notary node, party A node, party C node, and party B node. And we can go and inspect what that looks like. So you can see each of the folders here. And a Corda node is actually relatively simple. It's just the Corda software, a Corda jar, that we run using java-jar corda.jar. So that's the actual Corda software. There's a CorDapps folder that will hold all the CorDapps we have installed on our node. Those are still being generated. Oh, there you go. So there we can see our bootcamp CorDapps being installed on our node. And a CorDapp is just a set of classes, and all the classes in the CorDapp will be loaded onto the class path of the node at runtime It's really no more complicated than that. Then we're running in dev mode here, so we have some dev certificates. We have our logs, and we have a node configuration file. So here's all the information about the node. We also have this persistence.mv file, so this is the database file used by the node, and it will store all the transactions, the states, etc. So now we can run our nodes using this script run nodes here. So I'll just do build/nodes/run nodes. And we're just starting up the nodes here. So here we can see this is the notary here starting up. Then we've got party A starting up, party C starting up, and party B starting up. And so again, we're starting up a full node. We're initializing a lot of things, so it takes a little while. But once they're live, we'll have access to something called the node shell. We can actually start to interact with our node. There we go. So now our node is live. And now our nodes are stood up. We can interact with them. So one thing we can do is look at all the flows available on our node. So here we can see our token issue flow, as well as the example flow we provided for you. And if we just do flow start token issue flow, there you can see it's asking for an owner and an amount. And so running a flow is as simple here as going token issue flow and providing an owner, perhaps party B, and an amount, let's say 99. And here we're just running this from the command line. In practice, you'd connect to the node via RPC, and then you'd layer a kind of a UI on top of that, provide a server for interacting directly with your node. But this shell is a great way just to see your nodes are working. So let's kick off this flow. So that flow's done now. And to actually see the output, we're going to run another command, which will be vault query. This is just to look at the contents of our vault, look at the states we have stored. And here I have to pass in a contract state type. I'm just going to pass in the state type we defined earlier, which was token state. And there you go. So it's not the prettiest interface, but here you can see our transaction and the states. And so here we have a state, and we've got the issuer, party A, the owner, party B, the amount, the participants. So remember that the participants are the people who would store this transaction, so party A and party B. It's governed by this contract, token contract. It's got this notary, and so on and so on. So various pieces of information there. Now, this was issued to party B. So if I go to party B now, I can run the same thing. So I can run vault query, contract state type, Java bootcamp.token state. And here I can see the exact same information. So an issuer, party A, an owner, party B, an amount, 99, etc. So this is that blockchain guarantee that both participants see the same data. But importantly, Corda is a privacy-first platform, and so this was just an agreement between party A and party B. It had nothing to do with party C. And now if I go to party C and I run the same thing, well, what we'll see is that they weren't involved in the transaction, and so they don't actually get to see these tokens. And there you go. So even though party A, B, and C are all on the same network, only party A and B have been involved in that transaction, so only they've seen the states involved in that transaction. Party C on the same network hasn't seen anything.
Well, this brings us to the end of our Corda Bootcamp, and hopefully you've learned a lot about how Corda differs from traditional blockchain applications. It allows digital assets to be traded and legal agreements to be struck between legally identifiable counterparties rather than anonymous public keys. It also distributes data on the need-to-know basis rather than sharing confidential information with the entire network. Corda integrates with existing tooling and provides a flow framework to easily automate complex business processes. You should now understand how to build applications or CorDapps that run on top of the Corda platform. Our CorDapp addressed an IOU issuance use case, but CorDapps can be built to handle anything from energy trading to healthcare, any type of asset. Stay tuned for our next video where I will explain about the lab environment. Welcome to the lab section of this course. Included with your training materials will be a lab document. The lab document will include some quick shortcut keys for IntelliJ, so please take a look. Also, we discussed editing the colors and the presentation of IntelliJ. We're going to also take a look at that. Now, if we go down here, we can see that we will be there will be some steps for setup. If you are already set up, that's great. A lot of times you should be able to install IntelliJ. You may need to check your version of Java just to double check that the version of IntelliJ that you're using is supported. And then we're going to go through the tasks that are in the project. So we're going to open the Corda Training Template Master project, and we're going to load that, and we're going to go through each of the files. And in this case, what we are going to do is, since we don't have a Corda node, we're going to work on the unit tests, on the Kotlin unit tests, and then we're going to simply remove some comments and get the test to pass. So there are pretty clear instructions here of what to do. There are also instructions in your in the files themselves. So you can see here each file, the name of the file, and simply scroll down, and you can see the highlighted section is where you want to go, and you want to remove your comments there. And again, if we open the actual files, you'll see comments there. You do have the solution files. So the idea here is, because we can't ask questions, you can directly compare the work you are doing versus the solution. So let's open up IntelliJ and take a look here at some of the ways that we can change the settings. So here I've started IntelliJ, and what we simply want to do is click the open function, and we want to navigate to the directory where the project is. And we want the template master, so we'll select this and we'll click OK. And we want to import the Gradle project. So down here in the lower right hand corner, click all of these, click OK. And let everything load up. Now we have the project loaded. We can see everything came in. Notice here I've expanded Kotlin and Kotlin source, so we want to do that. And we want to move over here to the right from the drop down and make sure we select Kotlin unit tests. So a few things about the layout. What you can do is edit the colors. I'm not a big fan of those colors that you get out of the box. So one thing we can do, and this is in your notes, you can go here to File, and you can go to Settings, Editor, Color Scheme, and Color Scheme again. And the out of the box is something called Dracula, but you want default. And if you select default, you'll see it look just like this, which I think is much more readable. Again, this is all included in your notes. What we're going to do then is expand the Kotlin tests folder. And we are going to go down and we are going to follow our notes. So here are all of our tests. Again, we don't have an actual Corda node. So we're going to run a simulation. Our first exercise is going to be on the IOU state test. So we'll double click here and open it. And if we look here, we can see pretty clearly that
Thanks for watching. Feel free to add your questions as comments down below.
We have comments in here for task 1. So we can take a look here and you can see what needs to be done. And similarly, you can also open the solution file. If you're not a Kotlin expert, that's fine. There's also the Java source in here as well. Kotlin is preferred most of the time because it's shorter in syntax and it has some security features like nothing is ever nullable. Nullable can cause issues on distributed ledger technology. So Kotlin has some advantages to it. However, it is very, very close to Java. So if you know Java, you can pick up Kotlin pretty quickly. You can see here we have the class, we have, instead of the methods, we have the functions and so on. So what I'll do here is just go through this, go through the first one, and then we'll compare it to the solution. So for this first exercise, we actually have to go into the source. So what I did, if you look over here to the left, was in the Kotlin source, I navigated into main Kotlin under net Corda training and went down to the state package and opened up the IOU state. Just like our instructions say, we have to import 2 more classes or 2 more libraries. One of them is Java currency. And then I updated down here the input to the IOU state here. If you read the instructions, you'll see that we've got to remove the val string data property. And we're going to put the amount is currency here. Then we go back here to the IOU state tests and we look at the first test, class 1, and we can certainly navigate down a little bit. And so what we'll do is we'll remove the comments here on this first test and then run the test. So please also, as you go through, please look at the code, please look at the structure of these classes. You'll actually see things like parties, the contract state. This is all important here because this is everything that we talked about, and please try to read the comments. That's part of the lab as well, is to actually go in here and understand how these Corda contracts and Corda classes are built. So this is the actual source for the contract. This again is the state class. Let's go back to the test. And what I've done is I've removed these comments for the test. Please make sure you remove the comments for the annotation here. That is needed. That can be a little confusing. So each line, there are some lines in here that are commented out because they are just instructions or for learning or pointing something out. That's fine. So we have this function in this test class, completely uncommented now. And notice we also have the annotation uncommented. Don't miss that. And we have this little arrow here. We also have the Kotlin unit tests. We can run the test directly from this arrow, or we can say, we can click run and run Kotlin tests. But in this case, the fastest way typically is to just just to the left of your test, click on here and run the test, and you'll actually get some output here. And in this case, the first time you run it, it may take a little bit, but we can see here we've had success. Our first test passed. So, we actually have the solutions as well. So compare back and forth. Again, go to the second task, follow the steps in there. They're all in there. You also have the solutions. Go through one at a time. You may not need to go through every single test to begin to get the idea. However, I do recommend looking at the source code, both Java and Kotlin. Again, you can pick up Kotlin very easily if you know Java, and there are classes offered by coding boot camps in Kotlin. Kotlin, like I said, does offer some advantages because it does not explicitly allow nulls. And as you can imagine, in the world of in this kind of world we've been discussing, nulls can be a very big problem. So Kotlin gives us some advantages. So please go through the remaining tasks and again compare it to the solution. So the entire lab should take about another 30 minutes or so. Now that we got our first test to pass, let's make that comparison to the solution. So what we're going to do is just simply load the solution project. So you don't have to go back and forth between every single task. Compare it as you feel comfortable. But we'll make a comparison of the first task just for this example. So we'll say here, File, Open, and then we'll navigate to Corda Training Solutions Master Project and click OK. And I'm just going to clear everything here. We'll go into Kotlin Source, navigate down, and we'll open up the state tests. And if you take a look here, you will see that, and if we go back here to state, you will see all of the updates that were made here, the libraries that were imported, and also the updates that we made for the amount. So please compare these, and you might see a little more completeness on the solution as well, but you can certainly work around that. And so go back and forth, and if you run into trouble, first place to look is the solution, and you can use the solution to help one at a time work your way through the actual exercises. For more information on Corda sessions or other distributed ledger and blockchain technology courses, please consult your learning materials. Also for Corda private coaching sessions, please consult your learning materials. There are self-paced courses as well in the popular distributed ledger technologies and blockchain technologies, and some live blockchain courses as well. And here are some resources, docs, corda.net, please look there. There is a Stack Overflow, and Slack, you can join that. And these are great resources because you can directly communicate with the Corda community. So thank you again for watching this video and this course. I certainly enjoyed presenting to you. We hope you enjoyed it. And again, this course was a presentation of coding boot camps. Thank you again for your interest in this course, Introduction to Corda Distributed Ledger Technology Development. Again, a presentation of coding boot camps. So we had our introduction to Corda and how Corda works, and the vendor is R3 for Corda. The topics we covered, we discussed what Corda is and the difference between blockchain and distributed ledger technology. Sometimes there's a difference, sometimes there's not. We got set up, and we wrote our Corda distributed application, or our CorDapp, with our states, our contracts, and our flows. And this is what it looked like. It wasn't so bad. Congratulations, you've successfully finished this class. For some follow-up classes, again, please check back with coding boot camps. We have Introduction to Blockchain Cybersecurity, Learn Solidity Programming by Examples, Hyperledger Fabric for Developers, Ethereum Blockchain Development, Hyperledger Fabric for System Administrators, and Hyperledger Sawtooth for System Administrators. Once again, thank you, and we'll see you in the next class.